If you've been following along in our series, you should be comfortable enough with manual wind watches for us to now add the first complication, the self-winding system for automatic movements. Since the mainspring relies so much on these self-winding systems to keep the power high in a movement, it's extremely important that you understand how to troubleshoot and lubricate these systems properly to get the most out of your service. In this video, we're going to look at the top 3 self-winding systems you're more likely to run into as you start buying watches to repair. And by the end of the video, not only will you understand how they work, but you'll also understand how to troubleshoot them and properly lubricate them to get the most out of your service. And make sure you stick around, because today I've got a great lubrication tip that I'm sure you haven't seen anywhere else. So with that, let's jump right in. All right, so let's break down automatic movements into 2 categories to start. First, you have rotors that spin completely around. Okay, that's a rotor. And then you have another type that has limited travel. This is technically called an oscillator. And on this particular movement, this is a bumper movement. And it's called a bumper movement because of these springs right here that are actually bumpers. So that's where the term bumper movement comes from. Now, one of the big differences with an automatic system like this is that this is a ratchet system. So when the bumper movement or the bumper weight travels in one direction, it cranks it through gears that are on the oscillator itself. There's a pinion on the oscillator that engages with this geared ratchet right here. And as it goes across the geared ratchet, it causes the geared ratchet to move. And when it moves, this driving paw pushes down on a ratchet-toothed wheel and drives that wheel around. It's a pretty simple system, but it's very effective. Now, it does only wind in one direction, but that's okay. When you wear a watch all day long, this thing will get wound up to full capacity, fairly quickly. It doesn't take that long. So this is an effective system. And one of the other things that's pretty cool about it is the fact that, this is a style that was around in the 1950s. So not only is it automatic, but because of the way this was engineered, this movement is also hand wound. So just like any other hand wound movement, the stem turns the crown wheel, which turns the ratchet wheel, which winds the mainspring. And if you compare that to some other automatic systems that were used even in the early 70s, they were automatic only. They didn't have a hand wind option. So this is pretty nice. I like this one a lot. So let's go ahead and strip this one down, and then I will show you what to look for as far as inspecting it, and then, of course, how to lubricate it, and then we'll put it back together. Now, when looking at this movement, it looks like a typical manual wind movement. The stem turns the crown wheel, which winds the ratchet wheel, which winds the mainspring. One thing that you may notice that's different is that on the crown wheel on this movement, it has 2 screws instead of 1. So you can assume whenever you see 2 screws on a crown wheel that they are not reverse thread. They're going to be a normal threaded screw, just like you would see anywhere else in the movement. You'll also notice that there's 2 pivot holes. This one is for the rotor, and this one is for the lower pinion on the paw winding wheel. Now, the first thing that you'll notice about this pivot hole is that it has a bushing in it. A bushing, you could think of, is very similar to a jewel. A bushing is just a circular metal ring that fits into a larger hole, and it's usually put in places where there's a lot of torque. So if the torque starts to make the hole egg-shaped, then you can just replace the bushing so that you have a round hole again. This oscillator, of course, has a pinion that drives the geared rocker, and this lower pinion just fits in the hole and spins back and forth. You'll notice that the lower tip of the pinion is actually cone-shaped. This is done by the manufacturer to reduce friction. So to lubricate this, we're just going to apply a very small amount of HP 1300. The pawl winding wheel is actually made up of 5 separate parts. First, you have the body that holds the geared rocker, as well as the driving paw and the spring that goes along with it. Now, when cleaning these parts, I would take this driving paw off, but the spring, there's really no advantage of taking it off, so I would probably just leave that on. Looking at the other side, you'll notice there's a groove cut into the body of this part. That's designed to receive this plate, which allows this plate to slide around inside the groove, and it's this plate that the wheel will get mounted to. Now for lubrication, we're just going to apply 2 small dots on either side of the wheel. And as it spins around inside here, it will distribute the lubrication. Now looking at the actual winding wheel, you'll notice the pinion that drives the geared rocker, and you'll also notice the ratchet style teeth around the perimeter. Now, one of the things I want to point out is when you see a pivot that has a square shoulder, that square shoulder is where you want to put your oil. Because it's at a 90-degree angle, it will hold the oil in that area. If it was rounded, like you would see at the end of a balance staff, oil would flow away from there. But when you have a 90-degree angle, that's the spot you want to add your lubricant. So this plate sits slightly above the body of the geared rocker. So one of the easiest ways to install a wheel that has, a pinion on it is to use a bench block with holes. And then you can just set the wheel on and the upper pinion will go into the hole so that everything sits flat. And now you can start adding your screws in. Now, once the screws are in place, now we can get our driving paw in position. The driving paw has a notch on this end, which accepts the spring and holds it in place. Now, to lubricate the teeth, I would put a very small amount of HP 1300 on the teeth. I'm using this screw as a marker to see where I'm at. Then I would just simply rotate the teeth around, dragging the driving paw through the lubricant. Then add another small amount onto the teeth again. Continue rotating as the driving paw spreads the lubrication. Add one more drop of lubricant onto the teeth and let the driving paw distribute the lubrication to all the teeth. And then in the case where there's a little excess, I would just take a Q-tip with hexane and just wipe that off. Now we can install the pawl winding wheel. So we can see the pivot goes into the lower pivot hole. We want to make sure that we have at least a couple teeth that are open on each side of the pivot on the oscillator so that this does not come out from the oscillator. So to get it in place, you just turn the crown wheel just a bit while applying a little bit of pressure on the winding wheel paw. And now we can set the bridge for the automatic system. So on the bridge, you'll see there's a spring, and we want to be careful. That's the spring for the second paw, and that's attached with a screw. But again, in cleaning this particular spring, there's no advantage of taking it out. So I will just leave that in. And there you have your bumper movement. Now, the next self-winding system we're going to look at is one of the most popular self-winding systems out there, the Seiko Magic Lever. Basically what they did is they took the concept that we saw in the bumper movement of a paw driving a ratcheted wheel, and they just improved on it. This is a system that you're going to see in all the old vintage Seiko movements, and even in the newer movements that they're making today. So let's go ahead and jump right in. Now, we may be looking at one of Seiko's most iconic movements of all time, the 7S26, which is used in tons of vintage watches. And even though there are some simpler versions of the self-winding system using the magic lever, this is one movement that would be good to know because you're going to see it all the time, and it's relatively inexpensive. A lot of people end up swapping these movements out because this is not a hand winding movement. A lot of people like that option. So let's go ahead and break this one down, and I'll show you how it works. Now, these are the four main parts that make up the self-winding system for the Seiko Magic Lever. You have the first reduction wheel, the second reduction wheel, the paw lever, and the first reduction wheel clip. The first reduction wheel is made up of two individual parts. The main wheel, which has the teeth. These teeth interact with the pinion on the rotor. The center section is made up of a pivot, which has a groove in it that accepts the first reduction wheel C-clip, as well as an offset cam. Now, this piece is machined and then it's pressed into the center of the wheel. And the key to the magic lever system is that as the wheel turns in a circle, the cam, which is offset, moves the paw lever up and down onto the second reduction wheel. Now, when lubricating this cam, you'll notice that it has a square shoulder. So this would be the lubrication spot. And for this, I would use HP 1300, small drop on each side of the cam. And you would do this prior to installing the paw lever onto the cam. Now, the last thing I would mention about this wheel is that being that these two pieces are pressed together, this is a failure point on the first reduction wheel, because if this cam or this centerpiece becomes loose, then the wheel won't turn with the rotor. Now, if this cam becomes loose inside the wheel, you can correct that by using a staking set with a round tip punch to slightly close the hole on the wheel and then press the cam back in so that it's flush. Short of that, you just need to replace this wheel. Now you're looking at the paw lever as if you were looking down onto the movement, with the second reduction wheel being about right there. You'll notice the left side paw has a hook facing down. That is to grip the ratchet teeth that are on the second reduction wheel. And this pulls down on the wheel. And then the paw on the right side, as you're looking down on it, that little notch will push up on the teeth. So the left side pulls down, right side pushes up as it moves back and forth with the rotor. The one area of failure on this lever, which doesn't happen a lot, but it does happen, is that these teeth will get worn away, normally because there's absolutely no lubrication or there's excessive oils that have attracted dirt, and it just wears those tips away. So the only thing you can do at that point is replace the paw lever itself. So to assemble the unit, after you've lubricated the cam, then we'll install the paw lever. Now, one mistake that new watchmakers often make is reversing this when you're assembling it. So during the assembly, you want the paw that pulls down on the second reduction wheel to be on the right side, so that when it's flipped over, it'll actually be on the left side as you're looking down on it. So now with the paw lever in place, we can lay the bridge on. Now to install the C-clip, what I like to do is just get it in place. Then I use a pair of tweezers with a very stiff end. I put one of the tines on the plate, the second tine on the C-clip, and just pull it together. Now we just want to make sure that that C-clip is in the groove. And we can see that the C-clamp is in the groove. And now that we have the first reduction wheel in place on the bridge plate, now we can install the bridge onto the movement. Just like installing any train bridge, we want to make sure that all our wheels, pinions are lined up as best we can get them. And there we go. All the wheels are in place, first try. Now, once the train bridge is in place, we can install the ratchet wheel. Now, once the ratchet wheel is in place, we'll check to make sure the click's working, train's still running freely. Your next lubrication point is going to be the post for the second reduction wheel. For this, we'll put one drop of HP 1300 on this side and another drop of HP 1300 on the other side of the post. You'll notice that Seiko was kind enough to put the 3 lines on the second reduction wheel screw, indicating that it's a reverse thread. Now the last lubrication point are going to be the teeth on the reduction wheel, and we're going to put 2 small drops of HP 1300, one on each side of the wheel, and then we'll work the magic lever, which will distribute the oil on the teeth. It'll just help those little paws slide over the teeth a little bit easier. Now to lubricate the ball bearings in the rotor, we're going to put a drop of 9010 on one side and a drop of 9010 on the other side. Small amount, just a very, very small amount. And now we can install the rotor. Now we can distribute the oil in the rotor bearings, as well as the teeth on the second reduction wheel. Checking the function. Everything looks good. Now the last thing I would point out is the rotor is the last piece to go on. You notice I do not have the pallet fork or the balance in. That obviously needs to be in before the rotor. But that's it. That's the Seiko Magic Lever. Great self-winding system. Now the last system we're going to look at is ETA's reverser wheels. So we are looking at an ETA 2783 from around 1970 or so. And what we're looking at is the self-winding train that winds the watch. It's made up of 2 reverser gears, a reduction gear, which is right here, and the driving gear, which turns the ratchet on the mainspring. The reverser gears are each made up of two wheels with a series of levers sandwiched in between the wheels. The top wheels of each reverser engage with the pinion that's attached to the rotor, so they're always turning based on the direction of the rotor. The levers that are sandwiched in between the reverser wheels will lock the bottom wheel depending on the direction that the rotor's turning. So when you look at the top reverser wheel, the lower wheel is spinning free when the rotor is traveling clockwise, but when the rotor moves counterclockwise, the bottom wheel locks and provides the driving force to the reduction wheel. So clockwise, it spins freely. Counterclockwise, it's actually driving the reduction wheel. The second reverser operates just the opposite of the first reverser. In this case, when the rotor is turning clockwise, this reverser will lock, providing the driving force to the reduction wheel. But when it travels counterclockwise, the lower wheel unlocks and spins freely. There it is, locked and unlocked. So as the rotor spins, these reverser wheels alternately lock and unlock depending on the rotation of the rotor, so that the reduction wheel only turns in one direction. That's why they call it a reverser wheel. Now, let's strip it down and look a little closer. Now, looking at the underside of the automatic bridge, you can see the two reverser wheels, the reduction wheel, and the driving gear, which turns the ratchet wheel on top of the mainspring. Looking at the reverser wheel from the top, you can see the internal paws or levers that control the locking and unlocking of the two wheels, depending on which direction it's turning. If this part is worn out or anything is bent or something like that, or a tooth is broken, there's no fixing this part. You just need to replace it. The reverser closest to the reduction wheel has a pinion on it that actually drives the reduction wheel. This is the reduction wheel and its pinion, and this is the driving wheel and its pinion. The automatic bridge is fully jeweled, so the pivots for the reversers and the reduction wheel will be lubricated just like any other jewel. The only other spot is the post for the driving wheel, which needs a little dab of HP 1300. Unfortunately, lubricating the reverser wheels is not done by traditional methods. When you use a dip oiler, and if you were to put 9010 inside there, the reverser wheels spin so quickly, there's no place for the lubricant to stick to, and it all just gets thrown out. And the problem with that is that it contaminates all the parts. And then things start getting sticky and gummy, and you have quite a mess, and then you have failure. So the way reverser wheels are lubricated is with a special lubricant called Lubetta V105, which is a dip lubricant. So once the reverser wheels are perfectly clean, inspect them to make sure that there's no dust or any particles on it. And then we're going to dip it into the Lubetta V105 for 10 seconds. After we pull it out of the lubricant, we're going to blow it off with our blower until the rest of the solvent dissolves. And then we're going to place it under a dust cover and allow it to dry for 15 minutes. Once the reverser wheels are dry, then we can reinstall those into the bridge, and the reverser with the pinion goes closest to the reduction wheel. Now we can install the driving wheel and the reduction wheel pinion down. Now we can install the bridge, which is held by one screw. Now to lubricate the wheels, the two reverser wheels spin fast. So we're going to use 9010 on those two jewels. The reduction wheel spins slower, so we'll lubricate it with HP 1300. When reinstalling the bridge, this pinion on the driving wheel fits into a unjeweled hole by the ratchet wheel. We will not be able to get lubricant once it's installed, so we'll add a small amount of HP 1300 right into the square shoulder of the pivot. Once the bridge is in place, before we screw it down, we'll just test it out to make sure everything is meshing as it should. Now we can screw down the bridge. And then we lubricate the upper jewels as normal. So for the reduction wheel, again, HP 1300. And for the reverser wheels, we will use 9010. Now, if you were assembling this movement, it's at this point you would put the pallet, fork, and the balance bridge in. Now, you'll notice that on this rotor, the ball bearings are a sealed unit, but we still need to lubricate them. So for that, we use another special dip lubricant called Lubetta V106. So to lubricate the ball bearings, I put the Lubetta V106 in a small mason jar just to give me some room to be able to dip it down into. You really only need to get it in as far as the ball bearing unit is. So we're going to leave it in for 10 seconds, pull it out, and just like we did with the reverser wheels, we'll dry off the excess and then let it dry for 15 minutes under a dust cover. Now, once the part is dried, what I like to do, this is just something that I do myself, is I'll take a clean Q-tip dipped in hexane, and I just want to basically clean the area that was in the dip that really doesn't need to have any lubricant. So I just clean that up a little bit, and then I'll go on to the other side and just clean up anything that might be there. Now we can install our rotor, which again, if I was doing this for real, I would probably not put the rotor on until the movement was in the case, but just for demonstration purposes, I wanted to show you this. And there you have it. That's ETA's reverser wheels. You know, it could be very annoying to have to buy a special lubricant if you don't work on reverser wheels a lot. Luckily, there's a way you can do it with things that you probably already have. You can make the dip lubricant with some clean IPA alcohol or hexane, which is even better, and 9010. Let me show you how to do it. Just take the smallest container you have that's big enough for you to get your tweezers inside. And inside that container, with a clean syringe, add 33 drops of the solvent to 1 drop of 9010. And just mix it together. Just like using Lubetta V105. Now just submerge each reverser wheel into the solution for 10 seconds, pull it out, and then use your blower until all the solvent evaporates. Once all the excess has evaporated off, just put it under your dust cover and let it dry for 15 minutes. The solution will leave a very fine film of the 9010 on top of the paws and the levers inside the reverser wheel, basically doing the same thing that the V105 did. Well, that's it for today, guys. Thanks for watching, and because there's so much more to learn, I'll see you in the next video.